Hello students, I am Rajni Verma and in this video lesson I am going to discuss uniform circular motion. The motion of an object moving along a circular path with constant speed is called uniform circular motion. But before that, let us discuss a few terms related to the circular motion. These terms will help us understand the circular motion in a better way. First of all, we have circular path. What we mean by a circular path? A circular path is a path along the circumference of a circle. Let us suppose here we have a circle with center O and radius R. If an object moves along the circumference of the circle, its path will be a circular path. This path may be the whole of the circumference or a part of it, or suppose any arc. Any portion of the circle will form a circular path. Next we have a tangent to a circle. We shall also study about a circle as a polygon, how we can consider a circle as a polygon having a very large number of sides. We shall also discuss speed, velocity and acceleration in a circular motion, and we shall take up some examples of uniform circular motion in nature or around us. Let us consider a circle with center O and radius R. If we draw a line, any line, say L, so that it intersects the circle, it will intersect the circle in 2 points. It cannot intersect a circle in more than 2 points. But as we slide the length of the line L upwards or downwards, the length of the line segment, say AB, will become smaller or greater. When the length AB is the greatest, it forms the diameter. Diameter, as we know, is the longest chord of the circle. AB is a chord while L is a line which may be called as a secant. If we go on moving the line L, there will be a point P when the line will intersect the circle at that point only. And the line L will then be called a tangent. So we can define a tangent to a circle as the line which intersects the circle at only one point. I repeat, a tangent is a line which intersects a circle in only one point. Now let us see what are the properties of a tangent. First of all, the tangent is a line which intersects the circle at only one point. If we draw a line from the point P to join the center of the circle, this OP will form a radius, and this radius is perpendicular to the tangent. So the second property is that the tangent at any point is perpendicular to the radius drawn at that point. And the third property is that at any given point we can have only one tangent at that point. So there are three properties of a tangent. The tangent to a circle intersects the circle at only one point. It is perpendicular to the radius drawn at that point, and from one point or any one given point we can draw only one tangent to the circle. Let us see how a circle can be considered as a polygon. Here we take a circle such that we have drawn a square inside the circle. You know that we can always draw a circle outside the square touching all its vertices. So here we have a circle and a square inside it. Now suppose an object at P starts traveling around the perimeter of the square. So he will go in this direction, the object, it will go in this direction such that it will have to change its direction at 4 corners. 1, 2, 3 and 4, so that it can come back again to the point P. So here we have 4 sides and 4 times there is a change in direction. Now if we increase the number of sides of the polygon, and here we make a polygon having 8 sides, an object starting its motion at point A will have to change its direction 8 times before it comes back to its original position. So 8 sides, 8 times there is a change in direction. As we go on increasing the number of sides, here we have taken a polygon having 16 sides, so that if an object travels around this polygon, it will have to change its direction 16 times. And we can see it is clearly shown here that the polygon has almost coincided with the circle. If we increase the number of sides further, we will see that the number of sides becomes infinite. Number of sides become infinite, and the length of the sides is a point size, So it is clear that as we go on increasing the number of sides, the length of the sides becomes smaller and smaller, and at a time the polygon will coincide with the circle. So if an object travels along the circumference of the circle, even with a constant speed, it will have to change its direction at every point. Although the speed is constant, the direction will be changing at every point, that is continuously. So we can consider the motion along a circular path as a linear motion with a constant change in direction, a uniform speed but a constant change in direction. Now let us consider a circle with center O and radius R. We consider an object moving along the circumference of this circle. That is, the object is in a circular motion. Let us suppose that it is moving with a constant speed and the velocity is v. That is, the magnitude of the velocity is constant. In such a motion, the velocity is always directed towards the tangent of the circle at that point. So if P is a point, at point P, when the object is at point P, its velocity is directed towards the tangent. Again, if the object reaches the point Q, its velocity is now directed towards the tangent, which is in a different direction from the previous one. And as we have learned, the tangent is always perpendicular to the radius drawn at that point. So the velocity is in a direction perpendicular to the radius at that point. Here it is an important point to remember that although the speed is constant, the velocity is not constant, because we know that velocity may change either by the change in magnitude or by the change in direction. Here the magnitude of the velocity remains constant, but the direction is changing continuously. At every point the direction is different, but we can find out the direction. At any point the direction of the velocity is in a direction perpendicular to the radius. So if there is a change in velocity, there must be an acceleration. So we can say that this uniform circular motion is actually an accelerated motion. The change in velocity is only due to the change in direction. This change in direction is in such a way that the object has a tendency to always move towards the center of the circle. That is why the acceleration produced in the object is called centripetal acceleration. The acceleration is called centripetal or towards the center, seeking the center. Centripetal acceleration. So here we have three quantities: speed, velocity and acceleration. The speed remains constant, the velocity changes continuously, and the direction of the velocity is always along the tangent drawn at a point. Acceleration is always towards the center of the circle. This is called a centripetal acceleration. Acceleration is denoted by A. Now let us try to find out what is the magnitude of the speed. As we know, the magnitude of the velocity or the speed is given by the distance travelled divided by the time taken. Now let us suppose that t is the time to travel or to complete one round along this circumference. Then the speed v is equal to the distance travelled. Now in order to complete one round, the object has to complete a distance of one circumference, that is the distance is 2 pi r divided by time t. So this is the formula or the relation between the velocity, time and the radius of the circle. As we know, speed is the distance travelled per unit time. When the object completes one round along the circumference, the distance travelled is equal to 2 pi r, where r is the radius of the circle. So that v is equal to 2 pi r upon t. This is the relation between the speed, radius and time t. Obviously, the unit of the speed is the same, the SI unit as meter per second. Here we are talking about the speed. So speed is a scalar quantity, but velocity is a vector quantity. So that the magnitude of the velocity is 2 pi r upon t, that is v, and the direction is always directed along the tangent of the circle. And the acceleration produced is only due to the change in direction, so that it is known as centripetal acceleration. We had already discussed the word centripetal acceleration. There are several examples of circular motion around us. We can say the movement of hands of a clock, the tip of the moving blades of a fan, and also the motion of a stone tied with a string and swung around, so that if the string breaks at any point, the stone will fly away in a direction perpendicular to the radius. It does not fall vertically downwards, it rather flies away in a direction tangentially. There is another example. You must have seen a rotating fire wheel cracker or a firki in Diwali celebrations. In which direction do the sparks fly? Have you ever noticed? The sparks fly. Suppose this is a firki or a firework, when it rotates, the sparks fly in a direction always tangent to the points, to the circumference, and that is why it looks so beautiful, sending away sparks in all possible directions. So this is another example of a uniform circular motion. You can look around you and you will find many other examples as well. So we see that a circular motion is an accelerated motion, but still it is called uniform circular motion because its speed remains constant and the velocity changes continuously by a given amount, a fixed amount, and in a fixed direction. That is why it is called uniform circular motion. Let us try to look at these graphs and try to interpret them. This is a velocity time or a speed time graph. We see that it is a straight line parallel to the x-axis. What does it mean? It means that the velocity or the magnitude of the velocity remains constant. So the object is moving with a uniform speed. In this graph, it is a distance time graph. Here again, this is a line, a straight line parallel to the x-axis. We can say the object is at rest and its speed is 0. Here, the velocity time graph is a curve. It is not a straight line. It means that the velocity is not uniform. It is a non-uniform motion. Here, in this graph, velocity versus time graph, we see that the velocity is not uniform. From point O to A, it increases. Then from point A to point B, the speed is constant and then it starts decreasing until at point C it becomes 0. Here we have a distance time graph which is not a uniform, it is not a straight line. It is a curve and that is also not a well-defined curve. So it is a case of non-uniform motion. We cannot find the velocity as a constant quantity here. Here, look carefully at this graph. This is a distance time graph. It shows the motion of an object from A to B, from B to C and then C to D. There is something wrong here. From point A to B, it's okay. Then from B to C, the speed is constant because the speed is 0 because the object is stationary. From B to C, there is no change in the distance traveled. But from C to D, the position of the object at time D, when the point is at point, when the object is at point D, the object appears to be at two places simultaneously, which is not possible. There are two positions for the time t, at point D and also at point say P, which is not possible. So this graph is incorrect. There must be something wrong in the data or there is some mistake in the plotting of the graph. So students, in my next videos, I will be discussing some more graphs and NCERT questions, in-text questions, graphs and also numerical problems. So come back to watch my next video, and if you like my videos, if you find them useful for your studies, then please like, share and subscribe. Thanks for watching.